Hey everyone, in previous lecture I already discussed how we can solve linear homogeneous recurrence relation with constant coefficient. Theorem 1, if we have a characteristic equation like r square minus c1r minus c2 equals to 0 and we have two characteristic root r1 and r2, then solution is a of n equals to alpha 1 r1 power n plus alpha 2 r2 power n. I also discussed one example 8, which is based on theorem 1. There is a characteristic equation, also it have two root and we found the solution. Now example 9, find an explicit formula for the Fibonacci number. We know the Fibonacci equation, that is f of n equals to f of n minus 1 plus f of n minus 2, and initial conditions are f of 0 equals to 0, f of 1 equals to 1. So Fibonacci sequence are 0, 1, 1, 2, 3, 5, 8, 13 like this. So we need to add previous two, right, for the next number. Now find the characteristic equation for this. So f of n, that we can write as r power n equals to r power n minus 1 plus r power n minus 2. Now divide both sides with r power n minus 2. It will be r square equals to r power 1 plus 1. Right? So r power n minus 2, r power n minus 2 will be cancelled. Now take into left side. So r square minus r minus 1 equals to 0. And this is our characteristic equation. Now we need to find root of this. If we will multiply, it will be minus 1. If we will add, it will be minus 1. There are no such numbers. So we'll use the formula. What is the formula? R equals to minus b plus minus b square minus 4ac by 2a. Here coefficient of r square is a, that is 1. Coefficient of r is minus 1 and coefficient of 1 is minus 1. So a equals to 1, b equals to minus 1, c equals to minus 1. Now substitute all these value and find the r value. In place of b, we will write minus 1. So minus of minus 1 plus minus b square minus 1 square minus 4ac. 4 into 1 into minus 1, right? Divide 2 multiplied 1. So minus 1 multiply 1 plus minus 1 square, it is 1. Then 4ac. So minus plus 1 plus 4, 5 divide 2. It's 1 plus minus root 5 divide 2. Now r equals to 1 plus minus root 5 divide 2. So r1 can be 1 plus root 5 divide 2 and r2 can be 1 minus root 5 divide 2. So we got both r1 and r2. R1 is 1 plus root 5 divide 2 and R2 is 1 minus root 5 divide 2. Now solution of the recurrence relation equals to f of n equals to alpha 1. Then in place of R1 we'll write 1 plus root 5 divide 2 power n plus alpha 2 1 minus root 5 divide 2 power n. Next we'll compare with the initial condition, this power 0 and here this power 0. So f of 0 will be alpha 1 plus alpha 2, right? In place of n we write 0. Next f of 1. F of 1 will be alpha 1 1 plus root 5 divide 2 plus alpha 2 1 minus root 5 divide 2. So in place of this n we write 1, right? Now simplify this. Alpha 1 plus alpha 2 equals to 0. So what will be alpha 1? Alpha 1 equals to minus alpha 2. Now in place of alpha 1 substitute minus alpha 2 in f of 1. So in place of this alpha 1 we'll write minus alpha 2. So minus alpha 2, then 1 plus root 5 divide 2 plus alpha 2 1 minus root 5 divide 2. Now simplify this. Minus alpha 2 divide 2, then minus alpha 2 root 5 divide 2, then plus alpha 2 divide 2 minus alpha 2 root 5 divide 2. Now minus alpha 2 divide 2 plus alpha 2 divide 2, this 2 will be cancelled. We got 2 times alpha 2 root 5 divide 2. So minus 2 alpha 2 root 5 divide 2. So this 2 will be cancelled. So we got 1 equals to minus alpha 2 root 5. Alpha 2 equals to minus 1 divide root 5. Now substitute this alpha 2 value. What is alpha 1? Alpha 1 will be minus alpha 2. So it will be plus 1 by root 5. We got alpha 1 and alpha 2. Alpha 1 equal to 1 divided root 5. Alpha 2 equals to minus 1 divided root 5. Now substitute this alpha 1, alpha 2 value in the solution. We got f of n equals to 1 divided root 5 multiplied 1 plus root 5 divided 2 power n minus 1 divided root 5 multiplied 1 minus root 5 divided 2 power n. And this is our solution. This question was asked in GATE previous year question. So understand this, how we'll solve it. Next, theorem 2. Let C1 and C2 be real numbers with C2 not equals to 0. Suppose that r square minus C1r minus C2 equals to 0 has only one root, r0. In case of theorem 1, there was two root, r1, r2. Here we just have one root. A sequence an is a solution of the recurrence relation an equals to c1 an minus 1 plus c2 an minus 2 if and only if an equals to alpha 1 r0 power n plus alpha 2 n r0 power n. For n equals to 0, 1 till infinite, where alpha 1 and alpha 2 are constant. So in previous theorem 1, solution was an equals to alpha 1 r1 power n plus alpha 2 r2 power n. But here solution is alpha 1 r0 power n plus alpha 2 n r0 power n. Here we are multiplying one n and in both it is r0. So let's solve one example based on theorem 2. Example 10. What is the solution of the recurrence relation? an equals to 6 an minus 1 minus 9 an minus 2 with initial condition a0 equals to 1 and a1 equals to 6. So we have the initial condition and the recurrence relation. First we need to write the characteristic equation. So r power n equals to 6 r power n minus 1 minus 9 r power n minus 2. Now both sides divide by r power n minus 2. Here also r power n minus 2. It will be r square minus 6 r plus 9 equals to 0. So got the characteristic equation as r square minus 6r plus 9 equals to 0. Now multiplication will be 9, addition will be minus 6. So minus 3 minus 3. Minus 3 minus 3 multiplication will be 9 and addition will be minus 6. So r square minus 3r minus 3r plus 9 equals to 0. Now from this take common as r minus 3. Now from these two take common as minus 3, r minus 3. So got r minus 3. So r value equals to 3. Now we have one characteristic root. Solution will be a of n equals to alpha 1 then r power n, so 3 power n plus alpha 2 n 3 power n, right? And we have the initial condition alpha 0 equals to 1, alpha 1 equals to 6. So alpha 0 equals to 1 equals to alpha 1 plus alpha 2 in place of n will write 0. So this whole term will 0, right? So a0 equals to 1 equals to alpha 1. a1 equals to 6 equals to alpha 1 3 power 1 plus alpha 2 multiplied 1 multiplied 3 power 1. So 3 alpha 1 plus 3 alpha 2 that equals to 6. We have alpha 1 equals to 1, just substitute here. Here it is 1. 3 alpha 2 equals to 6 minus 3, it's 3. Alpha 2 equals to 3 divided 3, it's 1. We got both alpha 1 and alpha 2 as 1. Now after substitution of alpha 1 and alpha 2, we got a of n equals to 3 power n plus n 3 power n, and this is our solution. So if there is one characteristic root, solution will be alpha 1 r0 power n plus alpha 2 n r0 power n. If there is two characteristic root, then it will be alpha 1 r1 power n plus alpha 2 r2 power n. If there are three characteristic root, it will be alpha 1 r1 power n plus alpha 2 r2 power n plus alpha 3 r3 power n. If there are 10 characteristic root, then it will be alpha 1 r power n plus alpha 2 r2 power n plus alpha 3 r3 power n, like this alpha 10 r10 power n. So if there are more than 2, we can extend the theorem 1 and use as a solution, right? And if there is one characteristic root, we will use theorem 2. There are more about recurrence relation like divide and conquer, decrease and conquer recurrence relation. How we can solve the recurrence relation, all these I already discussed in algorithm. So I'm not repeating here. Here I just discuss how we can write the recurrence relation, what is linear homogeneous recurrence relation, how we can solve linear homogeneous recurrence relation. In next lecture I will discuss generating function. If this lecture is helpful for you, please like, share and subscribe. Thank you.